In this video, we're going to improve our fantasy name generator by implementing a little bit of machine learning. This is going to be a very basic machine learning process, but I think it's a useful illustration of how the general idea works. There's basically two stages to a machine learning process. The first is where you teach the program the types of behaviors you want it to employ. And then the second half is, as the computer is employing those behaviors, you give it feedback to say, yes, do more of this, no, do less of this. So in this video, we're going to focus on that first part, which for us means providing a list of names that we would like the computer to basically study and produce names that are similar to those names, or that follow similar rules to the names we provide. We still have our letter class that we're defining so that we can have our alphabet with all the right characteristics: uppercase character, lowercase character. Is it a vowel? Is it a consonant? We've also defined a new function called normalize. This is going to be important later to normalize the probability matrix. Basically, this is to ensure that the sum of each row in that probability matrix is 1. So you might recall from last time that the probability matrix is set up such that probability of I, j is the probability that letter I is going to be followed by letter J. So we played around a little bit with that last time, but there's 26 squared elements in this matrix that we would have to keep updating. And so we're going to get the computer to set up the probability matrix for us. Here we define the alphabet the same way as we have before. This is where we get into some new territory. This is where we're going to read in a list of names that we want the computer to try to imitate, or to create names based on the same patterns. I'm actually using a couple of files here. The first one is just going to initialize the array to 0. I could have done this manually in the program, but just in case I wanted to have some additional probabilities in there, we've got this default probability.csv. This is a file of all zeros, so we're starting the probability matrix as 26 rows and 26 columns of zeros. Then here we're going to read the list of pre-generated names. We'll come back to elves later. We're going to start out with human names. So I have a file over here in the other window called humannames.csv. And I pulled this off of the US Census website. These are the 2,000 most popular baby names in the year 2017 in the United States. So they ranked all the baby names by frequency, and these are the most common, the 1,000 most common boy names and the 1,000 most common girl names. Was very happy to see that my daughter is represented here. So she has the 173rd most popular girl name. Proud of you, sweetie. And I have a son on the way. Let's see if his name made it onto this list. That's close. All right, we'll call Randy close enough to Rand. We'll work with that. Okay, so both my kids are on this list, so that makes me happy. I don't need to do any editing. So basically what we're going to do here is read in this file. So reading a file in Python takes a few lines. Basically what we're doing is setting up this thing to be called CSV file. So this file name is getting attached to the variable CSV file. And then we're reading in the contents of the file to this name underscore reader. So this is recording the file contents. And so we need to access each item in the list. So here we're looping over all the names in the list. So this is going down first. Let's go up to the top again. This is going down Noah, then Liam, then William, then Mason, then James, then Benjamin, etc. So this is looping over all the names in name underscore reader. And then we're going to loop over the letters in that name. So we need to set up this probability matrix. So we're looking at pairs of letters. So we're looking at the current letter, and then we're looking at the next letter that comes after that. Notice we're stopping one element short of the list's length because we don't want to go, we don't want to have no letter to follow. And here we're reading in, we're converting those letters into their appropriate numbers. So these are the counting numbers that are associated with each of the letters in the alphabet. So for example, A gets 1, B gets 2, C gets 3, etc. And we have all that stored in our alphabet list thanks to our letter object. And then finally here we update the probability matrix. So we're basically counting the number of occurrences that letter num1 is followed by letter num2, and that's going to turn into the probability that letter 1 is followed by letter 2. So this is the heart of this algorithm. This is where the computer learns what the probabilities are, and then we just have to normalize those probabilities. We want them to be well behaved, so the total of any row to be 1, so that's this normalization routine here. And then we're going to write out the results to human.csv. We'll get to elves at the end of the video, because I want to show you that this does produce noticeable differences in the names that it generates. And then we write out to this file all of our probability matrix. So we're going to run this code and then look at the human.csv to see what probabilities it learns with regards to human names. So we'll hit F5, and it looks like it completed. I'm going to bring my folder over here. So my newest file in this folder should be human.csv. So this was just created a second ago. So we're going to open this. And so this is our probability matrix. It is 26 rows by 26 columns, one for each letter in the alphabet. Now, one of the things about machine learning is it's kind of difficult to extract a general lesson that the machine has learned. So like, for example, each of these represent, if I take a look at the first row, these are the probabilities that each of these letters, A, B, C, D, E, F, G, etc., follows the letter A. So we see that A followed by an A gets a relatively low probability. A followed by B and A followed by C gets about the same probability. A followed by D gets about twice that. A followed by E gets about half of these. A followed by I is about the same as a D. So basically the computer's extracting all these probabilities, and we're getting an idea of how often these permutations happen. But it's kind of hard to get a sense of, in general what the computer has learned, except in this row. You notice this row is all zeros, except there's a 1 for the U. You can probably guess which letter of the alphabet this is. Let's count and make sure. A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q. So the program has definitively learned that there's a 0% chance of any letter but U following a Q. In other words, there is a 100% chance that you should follow a Q with a U. So that's kind of neat, right? That's a universal rule we have. But there are some zeros that are, let's see, let's take a look at some of the other zeros to see what we have here. So for example, let's go A, B, C, D, E. Are there any zeros in the E row? No, there's not, because E is a common value. E, F. So for example, here we've got F never followed by B, never followed by C, never followed by D. That makes sense. With apologies to Fahugo gods out there. That makes sense. F never followed by M or N or P or Q or S. I'm a little surprised you never get an S. But it also looks like you never follow an F with a T in a name. So A, B, C, D, E, F. So, I mean, we certainly have words that have that. And I'm struggling to think of a name that has an F followed by a T. But basically that's an acceptable pronunciation combination that doesn't get captured here. So we might address that in the next video when we take a look at how we can refine this probability matrix by running the program. So this is our new probability matrix. It's the probability of this letter being followed by this letter, is the way to think of it. And so with that in hand, we can move on to our next version of the name generator. This works the same way as our last program did from the last video. We've got our letter object, we've got our alphabet. We've got down here the same generator and the same rules for selecting based on the probability matrix. The one difference we have is, instead of manually defining the probability matrix, we're reading in the probability matrix. So here, this chunk has replaced where we made our default setting for the probability matrix before, and we're reading in the human.csv file so that we can have the human probability matrix. So let's run this a few times, see what kind of names we get. Shanali. That automatically already sounds better than any of the names we've gotten so far. That sounds like a decently pronounceable name. It even sounds kind of like a human name. Let's run a few more times, see what we get. Turgraror. Oh, that sounds cool. Let's see. Chael. Oh, that's neat. I like that. Chael. Like a southern fantasy name. Waria. Oh, that's cool. Maybe that's Wario's girlfriend or something. Maybe. I don't know. And Rosia. That's kind of cool. Okay, so we have a small sample size so far, but already this is sounding better than the versions that we had before. What I want to demonstrate for you now at the end of the video is that this will generate some different sounding names based on the inputs we give it. So I'm going to come back over to our name initializer, and instead of human, we're going to read in elf.csv. And so I need to read in elfnames.csv. So the one with names in the name, in the file name, has the names in the list, and then the one that just has the species.csv is just a probability matrix. So let me show you what this spreadsheet looks like. So let's go to sort by name. Let's go to elfnames.csv. So this is a shorter list because I don't think I could find 2,000 names. That's a little bit weird. I don't know where that came from. We'll delete that. Okay, so I finished making my deletions of things with illegal characters. I think they got imported in wrong or pasted wrong or something. So when we run the name initializer now, it's going to read from the elf names and generate the elf.csv probability matrix for us. So we'll run this. And so now we come over to our folder. We've got elf.csv just created. And if you compare this to the previous one, you see that the probabilities are different. So here, for example, the probability of getting an A after an A is about 4.5%, whereas before it was 0.7%. So we are more likely in an elf name to get an A followed by an A, right? And that makes sense. It's formal, elegant, foreign sounding compared to human names, or at least English names, I should say. Let's see. So when I go over to the weighted generator now, I can change human.csv to elf.csv. And so the idea is when you run this code, you just specify whichever species of name you want, and you have a probability matrix for each one. So let's hit F5. So we got Kuleralul, which it's decently pronounceable. It definitely sounds Elven, right? It's got a lot of L's and R's rolling around the place. Let's run that again, see what we get. We get Nda. A little less on the pronounceable side, but of course we have less to work with, right? So it's hard to get the good rules down if we have only half the sample size. Ilat, I'm calling that one for my next elf name. Genianot. Let's try one more. Xaniatho. So yeah, so we're definitely getting different sounding names, right? All the ones before that sounded, I mean, they definitely aren't. I don't know of any folks that have these names for real, but they're definitely fantasy sounding. But these are definitely different sounding, which is pretty cool. So what we're going to do next time is make another modification to the weighted generator because we would like to be able to tell the computer about the feedback about the names that it generates and have it adjust its next generation accordingly. So we're going to add a portion down here that after it gives us the name, asks us for feedback about is this a good name, is this a bad name, and we'll take a look at how we get that set up. So thank you so much for watching. I will see you next time. Bye-bye.